This is the brief on the essential concepts for the Active Directory Domain Services Exam Review. So what are we talking about here? Active Directory is basically the central identity system for your organization. It's what controls who can access what. This is all about the logical architecture and the crucial automation skills you need to really master it. First, you've absolutely got to memorize the 5 FSMO roles. These are specialized domain controllers, and each one has a unique job that can't be duplicated. You've got the Schema Master, which is kind of like the architect, the RID Master, which allocates unique IDs for every object, and the PDC Emulator, which handles critical stuff like password changes and time sync. So how do you manage all this complexity? Well, that's where organizational units, or OUs, come in. They're the logical foundation for delegating administrative control. Second, let's talk about the connectivity chain. Active Directory sites define your physical network locations. This lets the knowledge consistency checker act like a smart traffic controller, building the most efficient replication paths. Now, the entire system fundamentally relies on DNS for service discovery, and, critical to logon speed, is the global catalog server. It holds a partial, searchable copy of every object across the whole forest, which really accelerates user authentication in complex environments. Finally, automation and cloud readiness are essential. PowerShell is the command line tool you need for any bulk operations, using common commands like new aid user to rapidly create accounts or set AD account password for resets. And if you're deploying a domain controller in Azure, there are 2 non-negotiables. You must assign static private IPs to the DCs, and you have to ensure the Azure Network Security Group allows all the core Active Directory ports. By understanding these interconnected roles, organizational structures, and required automation tools, you are prepared to manage Active Directory environments, both on-premises and in the cloud.
This is the brief on infrastructure strategy and Active Directory best practices. Okay, so if you're building out a new network, or maybe just redesigning the one you've got, getting that Active Directory foundation right is just absolutely critical. We're talking security, speed, scalability, the whole deal. This isn't just theory, right? It's about saving ourselves a ton of headaches down the road. So let's dive into the 3 things you have got to get right from the get-go. First up, keep it simple. The modern way to do this is a single forest, single domain. I know it's tempting to build something complex, but the simpler setup just cuts down on so much administrative overhead and replication nightmares. You'll save time and money. The only time you'd break this rule is if some major security or compliance rule absolutely forces your hand. Second, and this is a big one, naming conventions. Make them consistent and descriptive, especially for your domain controllers. The servers doing all the heavy lifting. A standard format like DC-Boston01 is going to be your best friend when you're troubleshooting in a hurry. It prevents so much confusion. Finally, let's talk structure, specifically your organizational units, or OUs. Now, a common trap is just making your OUs mirror the company org chart. Don't do that. Instead, design them around who needs to do what. We call it delegation of administration. That way, when you let a regional help desk reset passwords, you're sticking to the principle of least privilege. It's just way smarter. Seriously, get the structure, naming, and delegation right from the start, and you're building a foundation for a robust and, frankly, a lot less stressful Active Directory environment.
This is the brief on Active Directory delegation and admin bloat. So let's talk about a crucial security concept, the principle of least privilege. It's all about stopping what we call administrative bloat by making sure your teams, like the help desk, get exactly the permissions they need and absolutely nothing more. First up, delegation is your #1 tool against this. Think about it. Instead of making your entire help desk team domain admins just so they can reset passwords, you use the delegation of control wizard to scope those permissions way down. And please, I gotta stress this, you always delegate to a dedicated security group, never to an individual person. Just check the box for reset passwords, but only within one specific organizational unit, or OU. Second, you absolutely have to plan your OU structure, and that's because permissions have this thing called inheritance. See, when you delegate permissions at a parent level, they automatically flow down to all the child OUs underneath it. If you're not careful, you could accidentally give a team way too much access across different departments or even entire regional offices. And finally, you have to verify your work. Don't just set it and forget it. You need to check the effective permissions to make sure you didn't accidentally overgrant anything. You can do this right in the GUI. Just check the security tab on that OU's properties. Or if you're a PowerShell fan, a quick get ASIL command will show you the whole access control list. Look, effective delegation built on a smart OU structure. That's the only scalable way to minimize risk and really protect your Active Directory. This is the brief on Active Directory WAN replication optimization. All right, so let's dive in. We're talking about those critical Active Directory concepts network engineers use to manage traffic flow. The whole point here is to keep all your domain controllers synchronized. Without absolutely crushing those slow and, let's be honest, expensive WAN links. First up, effective replication really starts with site and subnet mapping. So, in Active Directory, a site is basically just a fast, reliable physical location, right? Think of an office building. Now, here's the absolutely crucial part. You've got to map your IP subnets to the right site. Because if you don't, your users could end up trying to authenticate against a domain controller halfway across the country, creating a ton of lag and just hammering that connection. Second, what happens when replication has to cross that slow WAN link between sites? Well, this is where the bridgehead server comes in. It's the one designated domain controller that handles that communication. It basically bundles up all the changes from its local site and sends them over the WAN in one neat package to the other site's bridgehead. Super efficient. And finally, the entire replication topology is automatically maintained by something called the KCC, or Knowledge Consistency Checker. This thing is basically a self-healing service. It builds the replication connections between domain controllers, and what's really cool is, if a domain controller goes down, the KCC just spots the failure and automatically reroutes traffic to a partner that's available. So, mastering 80 sites, the KCC, and the bridgehead server concept is essential for controlled, efficient data synchronization across all your separated networks. This is the brief on AD in the cloud, myths versus reality. So, you're a cloud architect and you're tackling that big move to Azure, right? Well, let's cut through the noise. We're going to cover the 3 absolute must-haves you need for a seamless and secure Active Directory hybrid setup. First up, you absolutely still need domain controllers running on virtual machines. Look, Azure AD is great for cloud-first stuff, but for your legacy apps, the ones that need that full AD feature control, you just have to deploy traditional Active Directory on Azure VMs. No way around it. Second, to make this whole hybrid thing work, you need a secure connection. We're talking about a site-to-site VPN. This basically links your Azure virtual network right to your company's network. Why? So Active Directory can replicate everything over to your on-prem domain controllers. The result? Your users can log in from anywhere with the same credentials and won't feel a thing. And finally, let's talk about protecting your data with Azure Backup. You have to set up backup vaults for your domain controller VMs, but here's the key. You must include a system state backup. This is super important because it backs up the actual AD database, the ntds.dit file. If a domain controller ever fails, that's what you'll need to recover. Remember, a smooth cloud migration isn't just about moving servers, it's about building smart connections, supporting those older apps, and having a solid recovery plan ready to go.
This is the brief on the hidden engines of Active Directory. So, if you're a sys engineer who's just pulling your hair out over slow logins, across a big multi-domain forest, well, the answer probably isn't where you think. It's almost always in 2 key systems, what we call the FSMO roles and the global catalog. These are the absolute core for authentication and, well, creating pretty much anything in your environment. First, you've got to check the PDC emulator. This is a big one. It's the only master for processing all password changes and, crucially, managing time sync across the domain. And that time sync, it's everything. Because the Kerberos authentication protocol totally relies on accurate time. So if that PDC emulator is slow or goes down, boom, you're looking at instant login delays and failures. Second, let's look at the RID master. So every time you create a new user or computer, it needs a unique security ID, or SID, right? Well, the RID master's only job is to hand out pools of these unique IDs to all the other domain controllers. If that RID master goes offline, eventually those controllers run out of IDs. And that means you literally can't create any new users, groups, or computers. Nothing until it's back up. And finally, let's talk about the global catalog server, especially if you're dealing with multiple sites. The GC's whole purpose is to make forest-wide searches super fast and to speed up logins across different domains. Now, if your global catalogs fail, yeah, local users can probably still log in, but any kind of cross-domain stuff like lookups or authentication, it's going to grind to a halt. You're going to see huge delays or just complete failures. So keeping a close eye on these critical roles and making sure you've got global catalog redundancy, that's really the key to a stable and responsive Active Directory forest.
This is the brief on PowerShell for AD automation. Okay, we need to talk about creating users in Active Directory. It's really time to stop using the graphical interface for everything. Our sources make it crystal clear. PowerShell is just way faster, it scales so much better, and it's the absolute key to handling bulk operations. So first, the biggest advantage here is reproducibility. Think about it. When you're clicking through the GUI, you might make a mistake. A script? Nope. It does the exact same thing perfectly every single time. This is how you can create, 100 users in seconds, or modify all of them at once with total consistency. The GUI just can't offer that guarantee. Second, querying your data becomes incredibly simple. Let's say you need to find all the disabled accounts for an audit, which is usually a huge headache, right? Well, now you just run one command, get AD user, with a filter that says enabled equals $false. And boom, it instantly pulls up a list of every single disabled user. And finally, a couple of things you got to remember to get started. All this power comes from the Active Directory module, so you have to load it first with import module Active Directory. And be precise with your syntax. The filter syntax is case-sensitive even if what you're searching for, like a username, isn't, so definitely watch out for that. For any admin who needs speed, automation, and repeatable results, PowerShell is the essential way to manage Active Directory.
This is the brief on the gotchas of Active Directory Domain Services installation. So, Active Directory Domain Services, or ADDS, it's basically the master phone book for your whole network. It controls who gets access to what. And, a failed deployment? It almost always comes down to missing one of three really simple steps. First, and this is the big one, you absolutely have to give your domain controller a static IP address. I mean, think about it. If its address is always changing, how are your computers supposed to find that master phone book? They can't. And just like that, nobody can log in. Second, installing ADDS isn't a one-and-done deal. It's a two-step process, and a lot of people get tripped up here. First, you install the role in Server Manager. That just gets the files on there. You're not done yet. You then have to click that little notification flag and promote the server to a domain controller. That's when you actually build your new forest or join a domain. Finally, when you're promoting the server, don't just fly past the Directory Services Restore Mode password. This DSRM password is your break glass in case of emergency key. It's totally separate from your normal admin password, and it's the only thing that's going to let you recover the database if Active Directory decides not to start one day. So yeah, getting ADDS right is all about locking down that static IP, remembering the two-step install, and setting that emergency password.
Welcome back to the deep dive. You've sent us the kind of source material that makes network administrators wake up in a cold sweat.
Yeah, a stack of dense study guides and lab notes covering Active Directory Domain Services, ADDS concepts.
Exactly. And instead of just burying ourselves in summaries, we figured we need a better way to extract the really high-stakes, must-know information.
Precisely. This stuff isn't for casual reading. It's designed to test your conceptual understanding, under pressure. So to give you the most efficient shortcut, we're going to run this as a mock oral exam.
I am officially the student today, standing between the domain and disaster, ready to prove I know these core concepts. The material is heavy, so our mission is to filter out the noise and just nail down the absolute necessities.
Think of this as a focused cram session. We're targeting the architectural concepts, the best practices that every administrator needs to know. So let's not waste any time. We'll start with the absolute baseline.
Alrighty.
Define Active Directory Domain Services for me. Then articulate the two absolute minimum pre-installation requirements that must be configured on a server before you can successfully promote it to a domain controller.
Okay, let's unpack this. ADDS is fundamentally the network's centralized master phone book and its security clearance system. It's responsible for managing all the identity objects, users, computers, groups, and, determining who can access what. The server that runs this whole service is called the domain controller, or DC.
Excellent definition. Now, those pre-installation requirements, what are the non-negotiables?
The study guide was very, very clear on this. The first critical requirement is a static IP address.
Non-negotiable.
Absolutely. Because if the DC's IP address changes dynamically, no other computer on the network can find it. And that leads to, catastrophic authentication failures.
That's the operational reason, right?
Yeah.
And to tie that into the identity system, remember that DC is also hosting DNS, which relies entirely on that fixed address. So what's the second mandatory requirement?
The second is setting the Directory Services Restore Mode password, the DSRM password.
Right.
And this password is explicitly separate from your regular domain admin password. It's only used for emergencies, like disaster recovery scenarios when Active Directory itself fails to start. If you forget this, you might not be able to fix your domain.
Good. Understanding the why, preventing failure, and enabling recovery. That's the key. All right, moving on to architecture. For efficiency, why does Microsoft recommend that most organizations stick to a single forest, single domain structure? And then explain how organizational units, OUs, are essential for administration within that domain.
The reason for the single forest, single domain model is simple. It's just cheaper and, frankly, less of a headache.
How so?
Well, a single forest means automatic trust between any domains you might add later. It shares one common schema, and managing replication is just far simpler than across multiple complex domain trees.
That makes sense for simplicity. But what if you're a massive global enterprise? Or you're going through a merger? Wouldn't you use multiple forests for that kind of strict regulatory segmentation?
Oh, absolutely. You would. But that's the exception, not the starting point. The single forest is the backbone.
Yeah.
And to make that single large domain manageable, we use organizational units, OU.
Right, the containers.
Exactly. They organize objects like users and computers, and they serve two vital roles. First, they let you apply group policies selectively, so you can push settings only to computers in the finance OU, for example.
And the second role.
Second, and this is essential for security, OUS allow you to delegate administration. The best practice here is to structure your OUs based on who needs to manage what.
So not just mirroring the org chart.
No, not at all. If the Chicago Help Desk needs to reset passwords, you create a Chicago OU, and you delegate that specific task just to them.
Perfect. Let's move on. ADDS is designed for multi-master operations, but certain critical changes have to be single master. Let's discuss the two forest-level FSMO roles. Describe the schema master and the domain naming master, and then tell me when it is appropriate to use the seize operation.
The FSMO roles. Flexible single master operations. I like to think of these 5 roles as, the CEO and the specialized department heads of the domain.
Good analogy.
They hold unique authority. And the 2 at the forest level are the highest. The schema master is responsible for changes to the blueprint of the entire forest.
Which is pretty rare.
Very rare. It's like editing the DNA of the domain. It only processes updates, like adding a new attribute field to every single user object. It usually just lives on the very first DC you ever create.
And the naming master?
The domain naming master. That one controls adding or removing domains within the forest. So if you wanted to expand your structure, this is the master that authorizes that operation.
Okay, now for the high-stakes procedure. You normally transfer a role cleanly. Under what specific catastrophic condition do you seize it?
You only seize an FSMO role if the domain controller holding it has failed permanently.
Permanently.
And cannot be brought back online. Seizure is an emergency move. If the DC is just temporarily offline, you have to wait for it to return. Because if you seize the role and the original one does come back,
You end up with 2 masters.
which can cause irreparable damage to the forest. It's a huge problem.
Excellent. Now let's shift to the 2 most operationally intensive domain-level FSMO roles. Explain the PDC emulator and the RID master. But what happens if the RID master actually breaks and can't be recovered? What's the immediate failure?
Okay, the PDC emulator is probably the most active FSMO role.
Yeah.
I mean, it's crucial for day-to-day sanity. Think of it as the domain synchronized watch. It handles time synchronization for the whole domain. It processes failed logins, and this is important, it's the first DC to receive password changes. This ensures that when a user immediately tries to log in with a new password, it actually works.
Even before replication is finished.
Exactly. Then there's the RE master, or relative ID master. This one is the key to creating unique identities. Every security object needs a unique security ID, a SECE. The RD master's only job is to hand out pools of unique relative IDs, RDs, to all the other DCs in the domain.
So what's the catastrophic immediate impact if that RID master is just gone?
The impact is immediate, and it is domain crippling. If the RD master breaks, all the other domain controllers will eventually exhaust their local pool of RD.
And once they run out?
Once a DC runs out, you can no longer create any new security objects in that domain. You can't onboard new employees, you can't add new servers, you can't create new groups.
So object creation just halts.
It's completely halted. You have to seize that role immediately to restore core domain functionality.
That's the high-stakes risk we were looking for. The RID master directly determines the domain's ability to even grow. All right, global catalog servers. They're specialized DCs for speed. What's the fundamental purpose of the GC? What information does it store? And what happens to a multi-domain forest if all of them fail?
The Global Catalog Server is all about fast searches across the entire forest. Its whole purpose is to let users find any object, no matter which domain it's in, without having to contact a bunch of different domain controllers.
Which speeds up logins.
Massively. And it cuts down on replication traffic. What it stores is the key to its efficiency. It keeps a full writable replica of its own domain's data,
Right.
plus a partial read-only replica of all other domains in the forest. That partial replica only stores the most essential stuff: name, email, phone number. The reason is pure efficiency.
You don't want to replicate everything everywhere.
Exactly. And the risk of losing all of them.
Yes. What's the impact?
If all your GCs go down in a multi-domain environment, the most critical failure is the inability to resolve universal group memberships. Users can't reliably log in, and services that rely on forest-wide lookups like Exchange will just fail.
Because the full list of those universal group members is only stored in the GC.
Precisely. That's why the best practice is to have at least one global catalog server in every Active Directory site.
Speaking of sites, site topology is crucial for managing network bandwidth. Explain the key difference between intrasite and intersite replication, focusing on frequency and the mechanism behind the slower one.
Okay, so in Active Directory, a site is a physical location connected by a fast, reliable network, a LAN. And replication is managed differently depending on whether you're inside or outside that boundary.
Makes sense.
Intrasite replication happens within that fast LAN. So because the connection is good, replication is really frequent. It runs automatically every 15 seconds up to every 5 minutes. The goal is just rapid synchronization.
Okay, now contrast that with replication between, say, New York and London.
Right. Intersite replication happens between sites over those slower, bandwidth-constrained WAN links. To save bandwidth, it's handled very differently. By default, it's scheduled to happen way less often, every 180 minutes or 3 hours, and the data being sent is compressed.
And what's the AD component that architects this whole topology? And what server role is vital for that intersite traffic?
The topology is automatically managed by something called the Knowledge Consistency Checker, the KCC. It's always recalculating the fastest path between DCs. For intersite replication, the traffic gets funneled through a designated bridgehead server in each site. It acts as the official gateway for all the WAN transfers.
We need to talk security now, the principle of least privilege. We want to avoid making everyone a domain admin. So how do we achieve that fine-grained access control for common tasks, like help desk support, using the built-in tools?
This comes right back to delegation and OUs. The goal is to make sure a help desk tech can reset a password for a user in Boston, but can't touch anything in the server admin's OU.
Of course.
The easiest and most recommended way is using the built-in delegation of control wizard. You get to it by right-clicking the specific organizational unit you want to grant permissions over.
And what's the non-negotiable best practice for who you delegate those rights to?
You always delegate permissions to security groups, never to individual users.
Never.
Never. You create a group like Help Desk Boston and grant that group the ability to reset user passwords. That way, when a staff member leaves, you just remove them from the group. Their access is instantly revoked. It's much more secure.
And much simpler to manage.
Exactly. The wizard then lets you pick granular tasks like read properties or create and manage user accounts, ensuring they only have the minimum privileges they need and only within that specific OU.
No technical exam is complete without PowerShell fluency. Show me the basic conceptual components for creating a single new user account, and then explain the high-level process for creating, say, 50 new users from a spreadsheet.
Okay, for a single user, the command is new AD user. Conceptually, you need to specify the user's logon name, their display name, the password, and crucially, the narrow path parameter.
Which tells it where to put the user.
Exactly, which OU the user object belongs in, and you also have to explicitly enable the account.
That's good for one. But what about automation? Why is using a CSV file in PowerShell so much better than just scripting 50 individual new AD user commands?
It's all about eliminating repetitive, error-prone manual entry. The high-level process for bulk creation is beautiful. First, you create a simple CSV file with standard headers like SAM account name, display name, and OU path. Then you use the import CSV CMDlet to read that whole spreadsheet into PowerShell. After that, you just use a for each loop to go through every single row. Inside the loop, you call new AD user, but instead of typing values, you dynamically pull the data from the CSV column headers for each user. It's accurate and it scales.
Finally, let's look at the cloud. Compare and contrast deploying classic ADDS on Azure virtual machines with using Azure AD now Entra ID for identity management. When would you use one over the other?
Deploying ADDS on Azure VMs is the classic hybrid approach. You're just running traditional domain controllers in the cloud's IaaS environment. You'd use this when you need full Kerberos, group policy, or you're extending your on-prem network with a VPN for legacy apps.
And you mentioned a critical requirement for those DCs in Azure, didn't you?
Yes, and it echoes our very first question. If you put a DC on an Azure VM, you must manually assign static private IPs to those VMs. If they grab dynamic IPs, they just fail as reliable name resolution providers for the rest of your cloud network.
Right. And the alternative?
The alternative is Azure AD or Entra ID. This is the cloud-native provider, a SaaS solution. It's optimized for cloud apps, single sign-on, and it has built-in features like multi-factor authentication. It offers simpler management and lower costs since you're not managing the underlying servers.
So the usage scenario boils down to
Control versus simplicity. Use ADDS on Azure VMs if you need those traditional AD features and granular control. Use Entra ID if you're a cloud-first company focused on securing access to SaaS applications. Professor, I think I survived the exam. We successfully navigated this deep dive, and for you, the listener, the core takeaways have to be those critical dependencies, right? Like the static IP and DSRM password for setup.
and the gravity of those FSMO roles.
For sure, especially the PDC emulator managing time and passwords, and the RID master keeping object creation alive, and of course the security practice of delegating rights using OUs and security groups.
And if we connect this to the bigger picture, it just reinforces that good AD architecture is all about planning. It's about efficiency and resiliency, whether it's the KCC automatically building replication paths or the global catalog speeding up searches. All these components rely on logical design. It's not magic.
And underlying all of that, we kept coming back to DNS. If AD is the master phone book, DNS is the address lookup system that lets the whole thing function. Specifically, understanding that every DC needs to be a DNS server to register those service locator records, the LDAP and KDC records, is paramount. If DNS is broken, Active Directory is basically invisible.
This raises an important question for you, the learner, to consider. We talked about replication frequency between sites. But when planning a large-scale AD implementation, how do you determine the optimal cost to assign to an inter-site link? Not just to save bandwidth, but strategically, to ensure clients always authenticate against the fastest, most reliable domain controller available to them. That's the kind of optimization that separates the experienced architect from the basic admin, something to explore further.